Welcome back, Dragons. I'm going to work on AIM 13 and show you some strategies we have not talked about in a very long time. And when we talked about it, we might have gone over quite briefly. So I am going to get us set up here. All right, notes, prime, composite, and prime factorization using factor trees. I'll put a printable on the Google Classroom for you. If you are unable to print, just handwrite it. Here we go. I can use prime factorization of two numbers to find the JCF. I can use their exponents effectively. Okay, so this one should be a little challenging because we haven't seen it for a very long time. Please feel free to pause the video and try out the vocabulary on your own. Use a pencil to see what you remember, what you don't remember. All right, here we go. We've got a word bank here, factor trees, composite, prime factorization, base, exponent, and prime. Blank numbers are numbers greater than 1 with exactly two distinct factors, 1 and the number itself. If you chose prime, you are correct. Good job. Blank numbers are numbers that have more than two distinct factors. If they have more than two distinct factors, they are called composite. A factor tree is a way to organize and help you determine the prime factorization of a number. Blank blank uses branches to show how a number is broken down into prime numbers. Factor trees. A power has two elements, the base and the exponent as shown. The whole thing is the power. The base is this guy, the exponent's that guy. Remember, it's not repeated addition, it's repeated multiplication. The blank of a power is the factor that is multiplied repeatedly in the power, and the blank of a power is the number of times the base is used as a factor of repeated multiplication. Which goes where? We only have two words left. The base of a power is the factor that is multiplied repeatedly. That's this guy. You would multiply him over and over again. The exponent tells us how many times to multiply him. It says multiply him 4 times. 1, 2, 3, 4. 4 times. Okay, let's make some factor trees. Determine the prime factorization of each number using factor trees. Then write the prime factorization using powers. All right, so we want to break down using factors. And we can go down our trees in different routes. But the final answer should be a match. So, two factors that multiply together to get 240, if one of them is 120, the other one is 2. Now 2 is prime, so I'm going to circle it, because that branch is completed. Now I don't try to do anything fancy when I go down the factor trees. I try to do things, use factors that come naturally to me. So next I'm going to do 60 times 2. Because 60 times 2 would get me 120. I'm going to circle 2 because it's prime. Now I'm going to break down 60, which could be 30 times 2. 2 is prime. That branch is finished. Now I've got 30. 30 could be 2 times 15. 2 was prime, so I circled it. That branch is finished. And now 15 can be broken down into 3 times 5. 3 is prime, and 5 is prime. So if I were to write this out in like an expanded notation, I would have 2 times 2 times 2 times 2 times 3 times 5. I would have 2 times 2 times 2 times 2 times 3 times 5. 2 times 2 times 2 times 2 times 3 times 5. Now we want to shorten that notation. We want it to be written using exponents only. So let's try it. How many 2's do you have? You have 4 of them. So that would change to 2 to the 4th power times, you only have 1 3, and you only have 1 5. That is prime factorization using powers. So the answer in the blank is 2 to the 4th times 3 times 5. If I were to multiply 2 to the 4th times 3 times 5, I should get 240. Let's see what my calculator says. 2 times 2 times 2 times 2 times 3 times 5. It's a true story. We did excellent. All right. Happy face. Determine the prime factorization of each number using factor trees, then write the prime factorization using powers. Okay, I'd like you to try this one independently, so if you could, pause the video so you can give it a go, and then resume the video to see if we got the same final answer. Okay, hopefully you took a moment to pause the video and try this one on your own. If one of the factors is 30, who was the other one? 30 times what gets you 360? Might have taken you a few minutes, but it would have been 12. Now we're going to have to break down this branch and this branch because neither one of these are prime. So on 12, I'm going to go 3 and 4. I like 3 because it ends the branch. 4 can be 2 and 2. End of branch, end of branch. All right, let's break down 30. 30 could be 2 and 15. 15 could be 3 and 5. End of branch, end of branch. Okay, in an expanded formation, it would be 2 times 2 times 2. Pulling out all my 2's. 3 times 3 times 5. So first you ask yourself, how many 2's do you have? You have 3 of them, so that's 2 to the 3rd power times. How many 3's do you have? You have 2 of them, so that's 3 to the 2nd power. How many 5's do you have? You have 5. You have 1. 1 5. So in the blank, you get 2 to the 3rd times 3 to the 2nd times 5. Pulling out trusty calculator, 2 times 2 times 2 times 3 times 3 times 5 equals 360. That's what we wanted. Yay! Alright, so that is how you create factor trees. And what's cool about factor trees is they can help us shortcut on finding GCF and LCM without having to do so many long steps. So that's why I wanted to present this to you today. Thank you for joining me.